Okay. As usual, my slide contains my biography, but sometimes my secretary cut because of this photo is much younger than real me. But today is okay. So I'd like to introduce our clean energy innovation from Kyoto University. Yeah. Ah, Kyoto University covers a wide range of the research field, but among them, there are four areas where we are especially strong: life science, energy, new materials, and quantum technologies. As for, sorry, energy and new materials, as you know, both are deeply connected. For example, in the development of the nuclear fusion energy, creating the material that withstand extremely high temperature and high pressure is essential. Similarly, in developing the technologies for the next generation solar power, progress depends on the advancing the materials that form the element of solar power. Kyoto University has earned worldwide recognition in the field of the industrial chemistry. In fact, it is a field that produced the most Nobel Prize laureate in the Asian research institution and the university in Asia. And more, it is proud of long history of the over the 125 years. This strong foundation is industrial chemistry continue to support the development of new energy and material. Don't work? Right. Yes. Oh, correct. Uh, at our university, we are always valued basic research, but just as importantly, we have worked on the bringing the many discoveries into the real world, turning the invention to the innovation. Some of these you might recognize in your everyday life, such as healthy drink, LED lighting, no lithium ion battery, and a drug for the cancer, innovative drug for cancer, as well as the financial engineering tools such as the option pricing model. And this work is never slowing down. We are pushing even the harder to create the new wave of the innovation. Today, I will give you a quick overview of R&D for energy technology in the campus. Then I will share one exciting example of the breakthrough that is ready to commercialize. This chart shows the university's energy research project grouped into three areas: the generating of energy, next generation storage, and using or the reuse or the cycling of the energy. In power generation, we are particularly pushing the frontiers of technology for nuclear fusion and next generation solar power. Together with the startups, we are leading the world in developing the key components that fusion requires, such as blanket, gyrotron, heat and fuel cycle system. Thanks to the Swiss academic institution and the European ITER. And in solar power, our university is developing the promising element perovskite. It is so thin and bendable. Based on this technology, we already established the very promising the startups. Yes. And more, new transparent elements that can use the infrared ray. It means that you can even get the solar power energy in the dark space. In storage, And we are at the forefront of all solid-state batteries and hydrogen fuels. And in reuse, we are already launching the large scale of the pilot project that capture the carbon and the nitrogen using the artificial photosynthesis, algae, and biomass, turning them into electricity, bioethanol, and even next generation fertilizer. These are just several examples of the energy-related R&D on campus that were ready to commercialize. Next, I will highlight the new breakthrough example. Last year, our president, Professor Minato, shared how fusion technology from the university is already expanding globally by our fusion energy startups. Today, I'll share the new exciting example of the non-combustion biomass power. Biomass power is promising the renewable energy source, but it's still facing the several major challenges to widespread adoption. First major challenge is efficiency. Biomass need much more fuel than oil, natural gas, or the coal to make the same amount of energy. Second challenge is fuel quality. Things like the wood or the coke waste don't always burn the same way. Sometimes they are too wet, sometimes too dry. That makes it hard to get steady power. And the third challenge is the issue for the transport and storage. As you know, biomass is heavy and bulky, so because of its hold water, it's not easy to move long distance or to keep in storage for a long time. These are major challenges we need to solve in make the biomass a stronger option for clean energy. Kyoto University, we've been working on a new way to solve these issues, and now it's almost ready for real use. The method is called wet chemical loop. Instead of burning the biomass, we mixed it with a special liquid. This let us create electricity directly while also collecting the pure CO2 at the same time. The results were amazing. The power efficiency is 2 to 4 times higher than the today's method. And the CO2 collected is nearly perfect in purity, 99.9%. Even better, this machine is very small. It needs only about 9 square meters. It's about the size of the parking spot. So it could fit in places like a small food factory, driving through for fast food, or the suburban restaurant. So imagine this. One day, restaurant might use their own electricity and make their own soda water or sparkling water and dry ice using the power and the CO2 from this system. To bring these kind of R&D into real-world business on the global scale, Kyoto University is actually promoting the worldwide expansion of the university technology, not only from us, but also the other universities. On the left side, you can see the KSAC, Kansai Startup Academia Coalition. That is the platform support the creation of university startup in the Kansai region. It now include the 29 universities. And also on the right side, you see the 9JP. It's the National Innovation Network for Entrepreneur Japan, which is the nationwide university startup ecosystem. More than 150 universities across Japan are major part of this network. And Kyoto University is proud to serve as the initiative for its international outreach. In other words, along with the platform and the ecosystem, Kyoto University is introducing the major Japanese universities technology to the world. Finally, I'd like to share our core philosophy to be a person who think, learn, and act proactively and independently with confidence and pride. In simple words, this is entrepreneurship. So entrepreneurship has been the very heart of Kyoto University for more than 125 years. That's my presentation. Thank you so much.